continue. So yeah, let me share the presentation again. Yeah. So we were talking about stack, right? So the key principle about stack is it's last in, first out. So we'll be placing so we'll be placing any item, any book, for example, in this case, a book, we'll be placing it on the top and on the last position, and we'll take away the last element, right? It's not the first one or the middle one that will take away, it's the last one. So last in, first out. So like if we match it to the current political phenomena, so if we yeah, so the advantages, as you can see, is we can easily add and remove new element, and it's ideal for this LIFO type of applications. Whereas disadvantage is less flexible, cannot easily access the first element. So if you want to access the first element, you will have to go all the way from the top to the in the case of books, you have to start from the top and go to all the way to the first element, right? So these are the advantages and disadvantages. Okay, so let's start. Maybe I'll do this with coding today. Where's Visual Studio? Questions, you can just raise if you have any questions. I saw some of you have shared in Facebook. Or among all, okay, so let me delete all these. So let's do stack from the coding itself. So let's create a class. All right. This one I'll do it in the main file itself, so you can always code it in the header file and call it from the main file. But for this example, I'll do it in the main file itself. So stack can be created using both arrays. Yeah, so it can be created using both arrays and linked lists, right? So if you remember, arrays and linked lists are the two physical data structures. Now stack is a logical data structure. So we'll be using one of the physical data structures, either array or linked list. So let me do it with arrays. Now, before doing that, let me just introduce the key attributes a stack has. So one of the key attribute is top. Variable is top. Top is a variable marking the index of the top of the stack. So as I mentioned, so even in the case of books, like a stack of books, so the top is the place where the end of the stack is marked, right? So we'll be taking item from the top, right? So basically a top is the identifier or indicator to the last element of the stack, right? So here, so if you can see in this example, so this is a stack, and this top variable is pointing to the last node or the last element of the stack. Now here the indexes start with 0, right? 0, 1, 2, 3, 4, 5. So the top is equal to 5 here, right? So actually you can use top variable in two ways. One is you can either point to the last element where a value is, or you can even point it to the over here to the element where there is no value, right? So I mean, either you can point it to the last element where there is a value, or to the first element where there is no value, right? So in both ways you can mark the end of the stack, right? Clear? So yeah, that's that variable. And after that we have this, let me explain capacity. The capacity is a variable marking the maximum size of the stack. So for each stack there is a capacity, right? For example, the capacity can be 10, 11, or any value. Like for in this example, assume your capacity is ends over here, right? You can see the arrow, right? So in that case, your the capacity of the stack is 1, 2, 3, 4, 5, 6, 7, 8. It can only hold 8 elements, right? The capacity is 8 if it ends over here, right? So that's a variable indicating the capacity of the size. And now this one data is it says the address of the array data structure. So it's, as you can see, it's a pointer. So we haven't still created the array. So this is just a pointer, right? If you remember, arrays can be created using pointers as well. So now here, this is the constructor, right? So in this constructor, so will be the input is a k. Here in this case, input is k, and k is a k indicates the size of the stack. So when we create the stack, here we pass the size of the stack, right? So the size is should be equal to capacity, right? So we basically say when we are creating the stack, whether this stack is a size of 10, 20, 100, or any amount. So that amount we'll have to pass, and we'll assign it to capacity, like over here, right? And then using the capacity variable, we now create an array of in this example, the stack is of integer type. So we'll create an array of integers with this capacity. So if the past value is 10, here we have created the array of 10, right? Clear? Any questions? No. So, and then we have the variable top, right? So we'll have to assign a value to top. So now can someone tell me now here top is equal to 0. So does this mean we are referring, so I mentioned that top variable can be used in couple of ways. I mentioned 2 ways, where one is top will point to the last node, right? Last node with a value. Or the other way is top will point to the last node without the first node without a value, right? So in both ways we can indicate the end of the stack, right? So in this example, if top equals 0, does that mean top is this type variable or this type variable? Which one? Can someone answer? Please, I don't want to name every time. Can someone answer? I know that some of you are very fluent in this, so please, someone. 3557 Dasanayaka. Which type of a point top is this one? So top equals 0 means which one?
End of the stack, sir.
This one or this one? So let's say this is A, this is B. B. Yeah. So yeah, quite right. So it's B, because now top is equal to 0 means, so at the moment we don't have any nodes in the stack, right? So if our top is of this type, so it shouldn't be pointing to 0, right? Because if it is of this type, we should point to a place where there is a value, right? The end of the stack. Now at the beginning there is no value, no elements. So either if top is of this type, probably we can keep top as -1 to indicate there is no value. right? Now we start top with 0. That means we are pointing to a let me, so write it over here. So let's say we created we give a capacity of 5. So 1, 2, 3, 4, 5. So now this is a stack of 5, right? So here top is pointing to the 0th element, but there is no value over here, right? The stack is empty. So that means the stack is of this type, right? So clear? Hope it's clear. So now let's go to the Visual Studio and let's try to implement that. I'll name the class as stack array because we'll be using list also to create stack. Now, what are the member variables? The first one, let's say top, and we have capacity, right? And again, data. So these three are the variables. So let's create a constructor. And we'll pass the value, the size. So now the first thing we need to do is we need to make sure our capacity is updated and is set to cap. So whatever the value it will pass, we'll reset it to the capacity. Next, we'll go with top equals 0. That means the second type of I mean out of the two types, the second type, right? And data equal new, right? New int and capacity. Clear? Is this clear? Amma?
Yes, sir.
Okay. Then let's create a couple of functions. Now that is there in the stack. So functions, there are two main functions. One is push, one is pop. Push is about insert, is the insertion operation where we push a value into the stack, right? So we'll be pushing it to the end of the stack. So that's why where this push word came from. So we'll be pushing it to the end of the stack. So let's try to implement that. So there's no return type, right? So we'll have to pass the value, right? Okay. So what's the first thing we need to do? So before inserting, what is the first thing we need to do? Someone? If someone answer? Here up, HMKDB 3601. What's the first thing we need to do? Based on your knowledge from data, the linked list and array, what's the first thing before inserting a value? What should we do first? Yes, here up. Here up, 3601.
Hello,
What's the
sir.
first thing we need to do?
I think we have to check whether the stack is full or not.
I'm really sorry, there was a vehicle passing by. What was it?
I think we have to check whether the stack is empty or not.
So that is actually we have to do, we are taking something out, right? So when we are inserting, one thing we need to do is we need to check whether our stack is
Full or not?
yeah,
The capacity.
exactly, full or not, right? So we need to check our stack is full or not. Now, how can we do that? So we have the capacity variable, right? Can someone tell me how to, so we have top variable. So using those two, can someone tell me how to check whether our stack is full? Lakshan 3649. Can you tell me how to check whether the stack is full or not?
Actually, I have no idea about that, sir.
So let's see. So if you remember now, let me draw and tell you. So can I annotate over here, right? Okay. So now, okay, let's say this is our stack. 1, 2, 3, 4, 5, 6. With size of 6, right? So this is our stack, and so we'll be inserting at the end, right? So our top, if you remember, our top will be referring to the last node where there is no value, right? For example, let's say this is our stack and all these are filled, right? Now the capacity is 6, right? Capacity is 6, and 1, 2, 3, 4, 5. 5 elements are filled, right? So this is the situation like that, and top will be pointing to this way. So there's no value over here, right? So this is a typical scenario. Now, if let's say we have inserted a value and this is also filled, now what happens? Our top will go to over here, right? Now, then what's the value of top? Value of top is 0, 1, 2, 3, 4, 5. It goes to here. It's 6, right? Top is 6, right? And all the values are filled. So one thing we can do to check whether our stack is full or not is simply we can use the top variable and see whether our top is equal to capacity or whether it is higher than that, right? So now if you remember, if you can see from this example, the capacity is 6, top is also 6. That means the stack is full, right? The top is pointing to over here, right? Because the indexes are starting from 0. So 0, 1, 2, 3, 4, 5, and the top is over here. That means top has gone out of the stack or out of the capacity. So we can simply check whether our top is equal to capacity or higher than that. Now, again, another question. If our top was, like I mentioned, top can be in 2 different ways. If we use top to indicate or to point to the last node, right? Now, in that case, our top won't be here. It will be pointing to here, right? When the stack is full. So in that case, what should be the condition over here? So top will be 5, capacity will be 6, right? Correct? So it should be, can someone tell me? Gunatilaka 3591.
Top plus 1.
Yeah. Oh, either that. So if you consider this example, top the top will be 5, right? Top will be 5, capacity will be 6. So we can do it in the other way as well, right? -1, right? So top +1 or capacity -1, right? So we can do it that way as well. Yeah. So for in this example, the condition is this one, and if the condition is this one, we'll output a message saying stack is full. Clear? Else. Now, if it is else, we can go up to 230, right? Yeah. So if it is else, that means so let me show it to you. So that means our stack is again something like this: 1, 2, 3, 4, 2, 3, 4, 5. Let's say a stack of 5, and our top maybe somewhere over here, and if top is over there, so these three will be filled, right? So top is over here. So there is a situation like this. So can someone tell me how to add a value now and insert this element? Three, 5, 8, 8. Gane good.
Yeah, square bracket top equals well.
Data. So we'll access the top. I mean, so our arrays data, right? Our arrays data. So we'll access the top index. So top is, so how to access the node element is using the index, right? So our index is top. So we'll access this one using, so like this data square bracket top. So what we have done is we have accessed this node or element. So not a node, is an element, and we should assign the value to that element. And then one more thing we need to do, increase the top index by 1. Correct? Yeah. So as I have received in the chat, yeah, that's correct. So this is the push operation, right? Clear? Any questions? It's exactly same thing, right, over here. Okay, next pop. Is this clear? Can we move to the next function, or do you need a minute? Just tell me even in the chat. So if you need a minute. Oh yeah, one more thing I forgot to mention. So now this was a new setup, like in the MIS. If you can go to the MIS and check under the criteria to pass the module, there was a criteria which I think most of us haven't explained, like in the academic stuff, which is, it wasn't there earlier. The criteria is, in addition to all that, where you need to get 35% out of the index exam, 35% out of the continuous marks. In addition to all that, you will have to pass also at least attempt all the continuous assessments. So the continuous assessments are like the project. Even if I give an assignment, everything you will have to at least attempt. So if you don't attempt, at least if you don't submit a blank paper, you won't pass the module. There was an instance like during the last results board, we found out that that some student haven't submitted assignment, and there was a discussion, and then it was pointed out that each student has to at least attempt all the continuous assessment, which is a must. So it doesn't matter whether you have the pass mark from continuous assessment or index exam. If you haven't attempted any of the assessments, right, so you will fail the module, right? So take note of that. Okay, so let's go to the next function, which is pop. Right. So pop is, as the name sound, it's about taking out the last element in a stack. Now remember, we are actually deleting the node. Right, this one. So it's a deletion operation. It's not just reading the value, it's about taking out the last element, right? So when we take it out, that element should be deleted. Clear? Okay, there was some questions. Stop like the index of the array or like the size variable in linked list. So now we are at the moment we are implementing stack using arrays, right? So in that case, top is the index. So it's exactly equal to index. However, if you define it that way, right? Now take note. So I mentioned top can be defined in two ways, right? One is where if I go to over here, so here there are two ways. One is top can be pointing to the element without a value, and it can point to the element with the last value. So right. So now if we use it this way, it's same as index, right? Whereas if we use it this way, it's again a sort of index, but you can't okay, so there was another question that links to this. So let me explain this again. Push. So yeah, so let me draw and explain. Okay, so now 1, 2, 3, 4, 5, 6, 7, something. Now I mentioned in our implementation, right? The way we do is in that our top variable will be pointing to an element where there is no value, right? Remember? So in this instance, these cells or elements are filled. There are values, right? However, for this element, there is no value. This is empty. So in the push operation, we'll be inserting. Now this is the capacity, right? Over here is the capacity. So we'll be inserting. We'll be pushing an element to the end, right? So our top is indicating pointing to this over here. So because of that, so in order to insert a value to over here, our code is, or the command is, so the data is the array, right? Array name, and index is top, right? So in this example, top is 0, 1, 2, 3. Top is 3, right? This is 3. And then we'll add a value. Clear? Then so value, so once we do that, there would be a value over here. So then we have to shift the top to the next element, right? Because we are always pointing to element where there is no value, right? So in order to shift, we increase it. Increment is by 1. Clear? Right? So this is that answered your question, Abhiratna? Did that answer your question?
Yes, sir.
Okay, good. Yeah. So maybe let me explain the other way as well. So for those who are interested. So let's say our top is over here, right? In that case, in the other way, so the top will be pointing to the last element where there is a value, right? Now we need to insert a value or push a value. So we will be pushing it to over here, right? So in that case, we first need to increment the top, right? And then do this operation. Clear? So if our top is like this, so first we need to shift it to over here, then do the insert the value, right? Is that clear to everyone? Can I get a verbal confirmation? Anyone? Is that clear? Jaya 3609, Jaya code. I don't remember. I can't see the other part. Jaya code also. Probably Jaya code. So is this clear?
Yes.
Okay. So let's go to pop. Now I mentioned the thing with the pop operation is about taking out a value, right? While we take it out, we'll be deleting that, right? Okay. So let's do it over here. Now here we need to check whether our stack is empty, right? Because we can't take a value out if there is an empty stack, right? Can someone tell me how to check whether the stack is empty? you are doing the soft skill modules, right? Where Dr. Prince is doing career guidance units. Aren't you following these soft skill modules? Yeah. So yeah, there's a comment. So that's correct. So in order to check whether our list is empty or not, with our implementation, what we can do is we can see whether our top is exactly equal to 0. That means, I mean, if the list is empty, top will be pointing to the first element, right? So that's the way we implement. So if it is the other way, so if we go with the other way of implementing top, so probably we'll have to check whether top is exactly equal to -1. Yeah, so I might be asking these sort of questions in the exam, right? So yeah, please take note of those differences. So if our top is exactly equal to 0, that means stack is empty, right? So we'll just print out a message. Now there needs to be something over here, because there is a return type, right? Return type of integer. We need to return something always, right? So let's just return -1. Usually, if you see the functions that's been implemented in Java or any other language, this is a usual practice where if there is no valid output, we sometimes output -1, right? So we can just check whether the output is -1, return value is -1, and if it is -1, we can understand the operation wasn't successful. So that's a practice that some programmers do. So now if the stack is not empty, right? So that means so let's say our stack is filled up to this point. Now our top is over here, right? Here. So pop operation, with pop operation, what we do is we need to take this one out, right? So can someone tell me how to do that? I believe you have enough knowledge to now even complete this, because we have learned linked list and arrays both. So can someone tell me how to do this? T715 Rasangi. What's the first thing we need to do? Rasangi. Rasangi, right, Rasangi. Can you hear me? T715. Rasangi, can you hear me? Okay, let's go with 3726 Sadeep. At least if you don't know, just tell me. Yes, Sadeep.
Top -1, top -1, and
Yeah, so you're correct in terms of concept. So first we need to decrement the top. So because the top is over here, right? So we need to shift top from here to here, right? There are a couple of ways actually. So you can just access it as top -1 like that as well. So so how I do it, I mean, just to be clear. So first we need to shift or decrease top, right? So by decreasing top by 1, so we shift the top from here to here. So now top will be pointing to this element. So we can now take it out, right? So this is how we access that element, right? Data square bracket top, right? So we can simply return that value. Right? So we just need to return that value. Is this clear? I have a question from this. Probably you might be also having this question. So now so far what we did, I mean, related to pop operation, have we deleted that value from here? Now in this example, have we deleted from the value from here? Anyone? Come on, a simple yes, no would be.
No, we haven't.
Yeah, correct. So we haven't, right? So we haven't, and can we delete it? The certain person, can we delete it? Now this is related to memory and heap and stack memory. Can you say whether we can delete this? Anyone?
Stack memory is not under our control, so it
Yeah.
will be deleted automatically.
Correct. So we can't actually, because now we have created this using arrays, right? So any array that we create, oh no, yeah, this is even though this array we created this using new still, so this is a little complicated. So now you might think, now we created this using new key variable, so this memory will be in the heap, right? So technically it should be possible to delete this value, right? Is possible to delete everything? So the answer to that, I wasn't supposed to teach this, but I wasn't planning on teaching this, but I'm just going into some advanced concepts. So if you don't understand, it's completely fine. So those who can understand, I'm just saying. So if you can, just try to understand. So the thing is, so this is created in the heap memory, right? Remember, with new keyword, this is created in the heap memory, right? So it's possible to delete everything. However, it's not possible to delete a single element in the array, right? So that's the answer. That should be the answer. A question might similar to this can come to the paper. I mean, we always put some hard questions as well. So yeah, just throwing it out there. Anyhow, with what we have done, the value is not deleted. However, with the way we are using the index, so we basically assume it as there is no value over here, right? Because now we shift the top from here to here, right? Now the top will be pointing to here, right? With our implementation, we assume that there is no value here. This is similar to empty, and we'll add any value to over here, right? So it's literally same as delete. Okay. Yeah. Okay, that is clear. And okay, so pop is what else? So these are the main two operations. So obviously there are other operations. Yeah, the traverse is there, right? Before traverse, yeah, let's do traverse. Okay, traversing is about going through each and every element of the data structure and printing it, either print or we can do any operation. However, it's the fundamental idea is about traversing, going to each and every element in the data structure, right? Yeah, so let's see how, I mean, it's quite similar to print operation, right? Let's see how we can do that. So yeah, as it says, so we have done it in the reverse way. So first need to check whether the stack is empty. So how we do that is usually by seeing whether top is exactly equal to 0. Now in this implementation, I have done it in the reverse way. So that means I have checked whether the list is not empty, right? How to do that is to see whether top is greater than 0, right? Clear? If top is greater than 0, that means the stack is not empty, right? Else, let's do that part as well. Else, that means the stack is empty. So in that case, we can just output stack is empty. I am just doing it in different ways so that you will also understand that each operation can be implemented in different ways, right? So don't get confused. I'm just doing it to show you that each and every operation can be implemented in various different ways. So it's just not one answer, right? So yeah. Yeah, so if top is greater than equal to 0, so we just need to iterate, right? So in order to iterate, we can use a for loop like this. So let's start with 0 and we'll go up till capacity, right? So just print. How do we access the element? Data. How do we access it? Someone? How do we access each element? Abheratna, 3520.
So,
How do we access each element in the stack? What
Data.
should be over here? What should I type here? Yeah, correct. So we start with 0. So we are basically accessing the each element in array, right? So it's quite simple as that. So we'll just print a space in between to separate the values, right? So there's something missing. Oh, I did a very bad mistake. So the mistake is over here. So it shouldn't be capacity, right? It should be top, right? So that was a mistake by my part. So I mean, the stack is not filled until the capacity, right? It's only filled up to the top mark, right? The top is the indicator of the last node, last element, right? So our for loop should only go up till top, right? Clear? Okay, so I'll just give a one minute to implement this. Then we'll try calling some of the functions and then let's see the results. Okay. Okay. Can we go to is the time enough? Can we try this out? Anyone still wants to complete the code? Please just either type in the chat or raise your hands if you need more time. Yes, clear, right? So how do we access the array? So the class name and just say and we have to pass a value. Let's say a stack of capacity 10, right? So what this does is it will create a stack of capacity 10, right? And let's try pushing some values. 5, 8, 7. Okay, then let's try printing. No, the word is traverse, right? So can someone tell me how does it look when we traverse? How does it look? The stack looks. What's the first element? What's the second element? And what's the third element? Am I audible? Yeah. Sankalpa 3735. What should be the first element when we run this?
7 is the first element.
No, right? So let me probably. So let's just see the results. Right. So what we have done here is we have created a stack of size 10, right? And so with push operation, what we do is we push elements to the end, right? End of the stack. So at the beginning, the stack was empty. So the first element will go to the over here, 5, right? The second push, that means this one will be pushed to the end, right? Now the top will be over here, right? So the 8 will be inserted over here, and 7 similarly will be inserted over here. So insertion it will happen at the end, right? We'll insert nodes or elements, the values to the end of the stack, not to the beginning. So that's why the first element is 5 and the second element is 8 and the third element is 7. Is that clear, Sankalpa?
Yes, sir.
Okay, cool. So now let's try getting, let's maybe add a couple of more. Then can someone tell me what should be the output here? Now if we print this, what should be the output? Someone? Vitarana 3791.
Hello, sir.
Yeah, what should be the output here? Pop.
Mm,
So we are. So
9 will pop.
sorry.
9 will
Yeah,
pop.
9. So right. So all the elements will be adding to the end, right? So we will be pushing the element, right? So everything will add to the end. And the last element to add was 9. So 9 will be somewhere over here. And the pop operation, what it does is it takes out the last element, right? So last in, first out, right? See, so it was inserted last, but it goes out in the first position, right? So the first thing we'll take out is that 9, right? So that's why it say last in, first out. So the result over here should be 9. Yeah, correct. See. Okay. So I mentioned that there are other operations associated with stack, right? So there are search operations, deletion operations, sort of many operations. So I'll give you one homework for you to do, because in the feedback I received, there was a couple of suggestions. Like one suggestion was to give you some homework. I'm not going to grade or anything, just for your curiosity and just to practice. I'm just going to give you this homework. So try to implement a function with the name search by value. Okay. See, let me. I don't think I have to write, right? It's so. Let me just write search. I'll just write the method declaration. So third, and there will be a value as well. So what should happen is, so it should return the index of first matched element, right? And if there is no many match, it should return -1. Okay. And clear? This is clear. Any questions? So what you need to do is, so you need to search the stack by the given value, and if there is a match, the first match, when there's a match, you need to output the index of the element that matches the value first, right? Now in this example, now our stack is something 58739. So that will be our stack, right? So if you call the function, if you call this function and input a value of 3, the output should be 0, 1, 2, 3. 3 is in the fourth element, right? So the output should be index, even though it's fourth element, index is 3, right? So the output should be 3. Clear? Any questions? Can you do that? Can you do that? Can someone tell me just yes or no, please?
Okay, sir, we can.
Okay. Okay then. I think stack is over. But I mean, I told you that stack can be implemented in 2 ways, right? One is using array, and the other one is using linked list, right? So let me, I'm not going to do it, the linked list, but let me explain how it can be done. Okay. So stack with linked list, right? Yeah. So you can probably do it by yourself. So now, if you remember, a linked list it's something like this, right? Right. Something like this, right? So this is a linked list. Now there's a pointer called head, right? Pointer called head and a pointer called tail, right? So again, couple of ways you can do this. Yeah. Let me explain how the push operation works. Like couple of ways you can do this. I'll explain in a way, in a certain way. So let's say you need to push a node, right, to this stack, right? So now this is your stack, right? These 4 nodes are there in your stack. So now you have another node, let's say temp, right? You need to push it to the stack. So you can push it either to the tail or to the head. So I'm going to explain how it can be done through the head, right? So in order to push this to this node, so you can simply, so this is a single linked list. You can simply connect the next pointer of this temp to the head, and you can move head to over here, right? You can simply do that, right? So how do you do? Temp dot next equal, what is it? Head, right? And then move the head to temp, right? So the push operation will be, so it will be pushing from this side, right? So I have pushed a node to the stack, right? And then pop is taking out the last element, right? So now which node we need to take out? So I told you, right? It's last in, first out. Dharmaratna 3568. So in pop operation, what's the node that we're gonna take out?
Head.
Yeah, head. Right. So basically this one, right? So if this is our linked list, so we basically need to take out the last node that we inserted, right? So how we can do that is, let me create another linked list. All right, so let's say this is the linked list and this is our head. All right, so this is our head. So with pop operation, what we need to do is we need to take out this guy, right? Take out this guy. So how we do that? So it's quite, I think we already learned this. So so let's create a temp and point it to head, right? So we create a temp pointer or current pointer or temp or anything. So we point it to this guy, and we now need to shift our head to over here, right? Because you will be taking out this guy, right? So basically shift the head equal head dot next. Clear? So we have shifted the head, and now if you remember in the signature of pop is, it's that we need to return it, right? So you need to return it. So I mean, let's just return the node itself. We can return the value together. So if we are returning the node, so this will be a node pointer, right? Right. So how do we return the node? Return. Which one we need to return? Temp. All right. We just return temp. So temp is the temp name. So temp is this guy. So we have shifted the head. So now our linked list start from here, and this is our linked list, right? So we just return this guy, temp. Is this clear? Any questions? Now, if you want, you can take this now down. Now, this is your second assignment, the second part of your assignment. That is, so your our assignment is to create stack, right? All the three operations of stack, right? The push, pop, and traverse. I already written down both, right? The pop, push, and pop is already here. So it's not quite assignment. So I have given everything. So implement stack data structure using linked list. Clear? Implement it using linked list, and again you need to submit both the linked list class, sorry, stack class, and the main function itself. You can write both in the same file as I did, or you can do it in separate ways. However, I need to see there is implementation of stack data structure and the main function where you call it and try out with different functions, right? So different examples. So now take note that when you try out different examples or try out different functions, you have a registration number, right? The last 4 digits. Now in your registration number, the last 4 digits, like for example 3557 3548, right? So you need to use these 4 digits as separate nodes, right? So let's take the example of 3548, right? If your registration number is this one, so you are in, what is the insert operation? Push, right? So you need to push all these values in the same way, right? So eventually I need to see 3, 5, 4, 8 created, right? and then you need to show me a couple of examples of pop, right? Clear? Any questions? Any questions? I'll give you some time to submit, like the deadline given for that assignment is 20th, right? I'll give you maybe end of this month. You can do this. Usually, I mean, we don't give so much time, like it's quite a easy assignment. So probably I'll give you until the end of this month. Okay. So let's decide the date itself. So 29th. Okay, you have to submit by 29th April. Clear? Any questions? If you have, please ask now. Otherwise, I think that's it from my side. I mean, regarding stack. So